Welcome to a quick video that's going to walk you through these enthalpy of hydration practice questions that I gave you on the practice quiz yesterday. So the first thing I would recommend that you do is you think back to the lab that we did in class. In the lab we did in class, we simply took a beaker, and the beaker had water in it, and we put some salt into that beaker. How much water is in this beaker? In the question, it's 40 grams of water, and you're going to put salt into the beaker. And the kind of salt that you're going to put is sodium hydroxide. You need to know the formula for sodium hydroxide. Now, how much sodium hydroxide do you have? You have 2.85 grams of it. So what I've done here is I've kind of outlined all the variables that they give me in the question, and I still have a few more. I have this temperature of the water. So my temperature initial of my water is 22.56 degrees C. And because the sodium hydroxide has an enthalpy of hydration that is negative, this is telling me that the delta H, my enthalpy of hydration for NaOH, is negative 44.51 kilojoules for every 1 mole of sodium hydroxide. That's telling me that this is exothermic. So that means heat is going to be given into the water. It's going from this salt into the water. And so the water, the final temperature, the temperature final of the water is going to be greater than 22.56 degrees C. How much greater, we don't know. We're going to find that out. So what we do is we first look at our variables and say, okay, I can take this grams of NaOH and I can convert that grams into moles, because 2.85 grams of NaOH into 1 mole of NaOH, you have to divide it by the molar mass, which is 40 grams, and I get 0.0713 moles of NaOH. Now, how much heat is associated with that number of moles? Well, if you have 0.0713 moles of NaOH, then when you multiply that times this ratio of energy per mole, you'll find out that negative 0.51 kilojoules for every 1 mole, you'll find out that you're given, or you emit 3.17 kilojoules of energy. Now that was heat that the salt gave off and that the water absorbed. So the water is going through an endo process. Alright, therefore the temperature is going to increase, and the sodium hydroxide is going through an exo process. Therefore, the energy is being given off for the sodium hydroxide. So what we do is we change the sign. We say, well, if the water went through an endo process, then this is now the Q of the water, but it's positive. It's a positive 3.17 kilojoules, and I can't use kilojoules in my Q equation, all right, because my C value for water, and I know that I have 40 grams of water, but my C value of the water is 4.184 joules per gram times degree C. So I'm in joules, so I need this to be in joules as well. My final temperature, we don't know. It is unknown, but my initial temperature is 22.56 degrees C. What I do here is I'm going to convert this into joules first. So I'm going to say, well, if I have 1,000 joules for every 1 kilojoule, then what I'm going to have over here is, I'll just erase this. What I'll have over here is 3,170 joules. That's the Q of the water. And I changed the sign because the water is endo. Like that, okay? Now this becomes algebra from here on out. So to solve for x, I'm going to solve it down here because I ran out of room. I'll put 3,170 joules. I'll divide that by 40 grams, and I'll divide that by 4.184 joules per gram times degree C. That will equal x degrees C minus 22.56 degrees C. Now, if you notice, what's going to happen here is joules are going to cancel out, grams are going to cancel out, and you're going to be left in degree C, because degree C is in the denominator. So when you divide this number by the C in the denominator, it becomes C in the numerator. So this ends up equaling 1.85, I believe. Let me just double check my math. This ends up equaling, if I take the 22.56, so I'm going to add 22.56 to both sides, like so. So I add 22.56 degrees C to both sides, and x degrees C ends up equaling 41.5 degrees C. And that is your final temperature. That's your theoretical rise in temperature, your theoretical temperature final of the solution up here, okay, of this solution. So that's your answer for number 10A. All right. Now what I'm going to do is I'm just going to put an arrow up here. This is 10A. That's for number 10A. Now, I'm going to answer 10C right here. And we're going to answer 10B down below, because 10B is a bit hard. And we're going to try to answer that one down below. So 10C is not too hard. Because this is an exothermic reaction, here is energy. I'm going to abbreviate that with an E. Energy is increasing along the y-axis. This is exothermic, so it goes like this. Here are the reactants, here are the products. And let me just change that once. Here it goes like this. There we go. These are the reactants, these are the products. And we'll label this with some arrows, some lines here. One line here, and another line there. What this first line is called, hopefully you know by now, it's called your energy of activation, or your activation energy. So this is the energy that you need to overcome in order to get the reaction started. Down here is another line. This is called your delta E, your change in energy from the reactants to the products. So you minus products minus reactants, and you get your change in energy. Products minus reactants is going to be a negative number, because reactants have more energy. So sodium hydroxide solid has more energy than sodium 1 plus aqueous ions and hydroxide 1 minus aqueous ions. These have less energy down here. Okay? Now we'll answer 10B down here. So 10B is going to get answered down at the bottom here. And so 10B, we'll just draw a little arrow down here. It's pretty hard. Okay, now what if your percent error was 35, not 36, was 35? Your percent error was 35.6%. That would mean that the absolute value of your accepted value minus your experimental value divided by the accepted value times 100 equals 35.6. Now you know the accepted value because it's written right here. This is the accepted value right there. So you can take that accepted value and you can plug it in here, and then you can multiply times 100. The only thing you have to solve for is your experimental value. So let's do that. So let's plug all this in. So it is a negative 44.51. So we have the absolute values. We have 35.6% equals absolute value negative 44.51 kilojoules per mole minus, excuse me, sorry, minus x kilojoules per mole absolute value divided by negative 44.51 kilojoules per mole times 100. So now as we go through this algebraically, you divide this side by 100 and you multiply it times negative 44.51 kilojoules for every 1 mole, and that eliminates this, and that eliminates that, and then you simply have a negative x kilojoules over here. You add x kilojoules to this side. You divide this negative 44. Excuse me, you have to look at your units. So these are in the same units. So you actually subtract. So this number ends up equaling, let me just look at my math. This number ends up equaling, my apologies, 15. So this ends up equaling around 15 kilojoules, and it's a negative 15 kilojoules per mole. And that equals negative 44.51 kilojoules per mole, absolute value minus x kilojoules per mole. Now you're saying to yourself, well, in algebra class, they told us that we need to, because it's absolute value, this could be positive or this could be negative. Fair enough, that's fine. But you have done this lab in real life, and so you should know that this value is going to be smaller than this value. And the reason it's going to be smaller is because you had a lot of errors. So you lost heat to the surroundings. So if we add 15 kilojoules per mole to that side, and we add 15 kilojoules per mole to this side, and we add x kilojoules per mole to that side, and we add x kilojoules per mole to that side, then what we have is x kilojoules per mole equals 28. Negative 28 equals negative 28 kilojoules per mole. That would be your experimental value. This is your experimental value of the delta H of sodium hydroxide if you have a 35.6% error. Okay? Now, it says to go a little bit further. It says, what is the temperature final equal? What is the temperature final equal? Well, if this was your experimental value, what you would have done was you would have taken the number of moles up here. All right, so I would have taken that value and plugged it in here, right? Because that would have been my experimental value. So I would have taken my number of moles of sodium hydroxide. I would have plugged it in for my experimental value, and then I would have found my kilojoules of the heat that was given off by the salt. I would have plugged it in here for the water, and then I would have found that my final temperature would have been lower than 41.5 degrees. So let's do that. So we have 0.0713 moles of sodium hydroxide. So here we go. We have 0.0713 moles of sodium hydroxide. And if we multiply this times negative 28 kilojoules for every 1 mole, what we get is, let me just do this for you real quick. So 0.0713 times negative 28 gives us a negative 1. And that's in kilojoules. So 1.996 kilojoules. Now this in joules is a negative 1,996 joules. I make this into a positive, so I have a positive 1,996 joules, and I set that equal to the 40 grams of water. I have the specific heat of water, and I have the delta T of water. So you're again going to solve for your final temperature when you know the initial temperature was 22.56 right there. Alright, and notice the Q value is smaller because you had error, you lost some heat. So 22.56 degrees C, this is X, and now it becomes algebra again. We divide this number, let's change the colors. We divide this side by 40 grams, and we divide it by 4.184. These ends up canceling out, and then you add 22.56 to this side, and you have your X degrees C. So what that ends up equaling is, let's multiply that times 1,000. Let's divide that by 40, and divide it by 4.184. And then add 22.56 to it, and you get, oh, so sorry, I made a mistake somewhere. You get a value of, I did the math wrong, 1,996 divided by 40 divided by 4.184 plus 22.56. Okay. So X degrees C ends up equaling 34.5 degrees C. And this would be your temperature final if you had a 35.6% error. Okay, if you had that. Alright, so that's a hard question. I won't give you one like 10B on the test. I could give you 10C, that's fair game. I could give you 10A, that's fair game on the quiz, but I won't give you 10B. It's too complex. We haven't practiced it enough. So use this video to help you study for 10A and 10C, and I will post an answer key for 11 as well, but no video for number 11.